Hello there. This is video number 22. And it is chapter 4, section 7. And yesterday, well, the last video that we did, video 21, was about 3x3 equations, and you solved them using 10 steps. These are also 3x3 systems of equations. These are solved a little bit differently, though, because they have a missing term, at least. And that's the big deal here. That's how you're going to tell these apart from any other ones. So let me give you an example here. The last section was chapter 4, section 6. This is chapter 4, section 7. Let me just lay out what a problem looked like from chapter 4, section 6. We had one where equation A was negative 2x plus 5y minus z equaled negative 3. Equation B was 2x minus 6y plus 2z equals 2. And equation C was 5x plus y, this was actually the last example in that video, minus 4z equals 21. And the big thing here that I want you to note is that all three equations contain all three variable terms. Okay, and what I mean by that, if you look up at A, there's an x, a y, and a z. Look at equation B, there's an x, a y, and a z. Look at equation C, there's an x, a y, and a z. So when you have all three equations with all three terms, that's when you're going to use the 10-step process. From 4.6, okay? Well, here's what these problems are going to look like in this section. And we're going to do at least 3 examples because they're all just a little bit different from each other. But in this one, equation A is x minus 6y plus 5z equals negative 27. Equation B is just negative 6z equals negative 12. And so you can see right there that z, if you divide both of these by negative 6, z is equal to 2, right? Right off the bat, you already know one of these values. So these should be easier, I think. And equation C is x plus 6y minus 4z equals a positive 27. All right, so here's your goal with these. Now, equations A has an x, a y, and a z. Equation C has an x, a y, and a z, but clearly B does not. All right, and so when that kind of thing happens, your goal here, let me go up the page just a little bit. Your goal is to first use substitution to create a 2x2 system that contains the same variable terms. Oops, I forgot the word same. The same variable terms. And what I mean by that is either x and y, x and z, y and z, both equations have to have the same thing. So if you kind of think ahead a little bit here, let me point out where this is going to go. We know that z is 2, right? So if I take that information and using substitution, I substitute the z right here, and I substitute the z right here. Can you tell just thinking ahead, that this whole 5z term is going to turn into a number that can then be connected to this negative 27 over here. Those will be like terms, leaving you just an x and a y on the left-hand side. In equation C, the same thing would happen. The 4z term will turn into a number. I'll move that number to the right-hand side, and I'll combine it with the 27. Essentially creating equations D and E without doing all the elimination you had to do yesterday. So let's see how that's going to work out. So I'm going to take equation A. Oh, I want red. I'm going to go backwards. Red. Okay, so equation A is x minus 6y plus 5z equals negative 27. And we're going to let the z be 2 because of equation B up there. So x minus 6y plus 5z. So this is really this, right? I'm just going to skip a step and put the 10 in here. Then I'm going to move the 10 to the other side. And I have, this is equation D, x minus 6y equals negative 37. Okay? Now I'm going to essentially do the same thing with equation C. Purple. C is x plus 6y minus 4z equals a positive 27. Well, we know the z is 2. So this is x plus 6y minus 8 equals 27. I'm going to add the 8 and add the 8. And I have x plus 6y equals 27 and 8 is 35. And this becomes equation E. So now I have where we ended up after like 6 steps yesterday. I have equation D and I have equation E. So what I'm going to do is stack those on top of each other over on the left-hand side over here. So equation D is x minus 6y equals negative 37. Equation E is x plus 6y equals 35. And in this one, we don't have to actually do anything for elimination to happen. You can see if you add down, the 6y's will eliminate themselves, giving us a 2x equals negative 2. So x is going to equal negative 1. Okay, so we now have 2 of our 3 variables. Now I can plug x back into either D or E. Let's take equation E because it just looks a little bit nicer. So I'm going to take E, which is x plus 6y equals 35. X is going to become a negative 1. I'm going to add a 1 to both sides to get rid of the 1. So I have 6y equals 36 and y equals 6 when I do that division. So now my answer, as an ordered triple, is negative 1 for x, 6 for y, and z was given to us up in the problem, essentially. That's a 2. Okay? I'm not going to go through the checking process, but that should happen. Now, each of these are going to look a little bit different, and they all require you to do just a little bit of problem solving in order to figure out how you want these things to work out. All right. Let's go to the next example. This one, I like to label these all the time. This one starts out with equation A as negative x minus 5y equals negative 8. Equation B is x minus 5y minus 6z equals negative 20. And C is negative 3x minus 5z equals negative 24. Excuse me. So what you want to try to do here, again, we want to use substitution. This is a little weird because equation A has an x and a y. Equation B has all 3 terms. And equation C has an x and a z. So one of the methods, remember, we want to use substitution. So if you can easily solve an equation for a variable and then plug it into other ones, that's what we're going to do. So I'm going to here use equation A, and I'm going to solve for x, which means get x by itself. And so if I do that, I start with negative x minus 5y equals negative 8. I add a 5y to both sides. So negative x equals 5y minus 8. And then I can't leave that x negative, so I'm going to divide everything by negative 1. And I get x equals negative 5y plus 8. And then what I'm going to do is I'm going to, let's use a highlighter, I'm going to take negative 5y plus 8 and put it anywhere there's an x in the equation I didn't just use. So I'm going to put that right here, and I'm also going to put it right here. And what that will do is leave me just y's and z's in both equations, giving me eventually D and E. So you want to use your other equations at this point. So I'm going to sub this into any other equations, not A, because that's what it started out as, and simplify, and then see if I get my 2 by 2 system. I know that it's going to happen here. You might need to see it all laid out before you actually see it happen. But I'm going to take anywhere there's an x, I'm going to put this negative 5y plus 8. So in equation B, the x is going to become negative 5y plus 8 minus 5y minus 6z equals negative 20. Okay, I'm going to drop the parentheses here. There's no coefficient in the front, so it's not necessary. Move any constants to the other side. So that means I'm going to subtract this 8 off of both sides and combine any like terms. Negative 5y and negative 5y is negative 10y minus 6z equals negative 28. And essentially, again, this becomes equation D. And we'll come back to that in a minute. Okay. Equation C starts out as negative 3x. The x is going to become negative 5y plus 8. So I'm up here, right? And then minus 5z equals negative 24. Now I've got to do some distribution first. So I get a 15y minus 24 minus 5z equals negative 24. If I add a 24 to both sides, don't let that freak you out. We're going to get a 15y minus 5z equals 0. That can happen. Don't worry about that. And this is equation E. Okay, so now I'm going to use equation D and equation E. And notice they both have a y and a z variable. So now I have a 2 by 2 system that I can utilize effectively. Let me stack those on top of each other. So I'm going to scoot this down a little bit. Okay, in black, here's equation D is negative 10y minus 6z equals negative 28. And then E is 15y minus 5z equals 0. So what pops into my head first, I'm going to actually make these 30s to get rid of the y's by multiplying this guy by a 3, which will give me a negative 30, and this guy by a 2, giving me a positive 30. Okay, so let's see what happens when I go this way. I'm going to get 3 times D is negative 30y minus 18z equals 30, 60, 90, 2, 4, 6, 84. I did that without a calculator. I'll go back and check if I get an error somewhere. And then when we move this guy, this is going to be 2 times E, and this is going to be 30y minus 10z equals 0. Add down. We're going to get a negative 28z equals negative 84. And 3 times 28 was 84 from that other problem. So when we divide by a negative 28, divide by a negative 28, we get z equals a positive 3. Okay? Now, what can we do with that z? Well, we can't plug it in back up here yet, right? There is no z in that equation, so that doesn't help me out. But I can plug it into either d or e and get an answer. So I'm going to go into e. All right, so here's equation e. 15y minus 5z equals 0. I'm going to let z be 3. So 15y minus 5 times 3. 15y minus 15. I'm going to move the 15 to the other side. That's going to change its sign, right? I'm going to add a 15, add a 15. And y equals 1. Now I can plug the y equals 1 back into this guy. I don't have any space. X equals negative 5y plus 8. X equals negative 5y plus 8. All right, so now we can plug the y in over here. And x equals 3. And so our ordered triple, x, y, z, looks like that. Okay, so this was a little different from the first one in that you had to substitute an expression, not just a value. And that's going to happen in the third one as well. And that third example is going to look like this. And this is the last one. So we're going to have equation A is going to contain 6x plus y equals 6. Equation B is going to look like y plus z equals 8. And equation C looks like 9x minus z equals negative 1. Now take a look at those. Equation A has an x and a y. So let's just, over here, I have an x and a y. Equation B has a y and a z. Equation C has an x and a z. So I don't even have two equations that are the same in any of these. So we definitely need to use substitution. Again, when you substitute, I would look to solve for a variable that has no coefficient. So that gives you a few options in this problem. And really, all of you could do this problem differently and end up with the same answers. I could solve for y in equation A. It has no coefficient, right? It's a 1y. I could solve for y or z in equation B, or I could solve for z in equation C. All right, well, I think I'm just going to work from top to bottom, to be honest with you. So for me, what I'm going to do is I'm going to start with equation A, and I'm going to solve for this y right here. So if I start with 6x plus y equals 6, and I move the 6x to the other side, I end up with y equals negative 6x plus 6. So now if I plug this in anywhere there's a y, well, let's see what happens. If I put it in here, I would put that in here. I would have an x and a z in that remaining equation, right? This y will turn into an x because I'm going to put that in there. There's already a z. There is no y in this equation, but it also has an x and a z. So this would work in terms of B and C would become my system of two equations with the same variables. All right, so what we're going to do is, let me get rid of these green dots and these underlines. Get rid of that underline. Get rid of that circle. All right, so we solved for y in the first equation. Let me get rid of these. So what we're going to do now is we're going to substitute negative 6x plus 6 in for this y right here, okay? And that's going to look like the y becomes negative 6x plus 6 plus the z, that's this plus z, equals 8. I don't have a coefficient, so there's nothing to distribute by, so I can just drop the parentheses. Move the 6 to the other side by subtracting off a 6. So now I have negative 6x plus a z equals 2. And this becomes my equation D, essentially. And then look at equation C. Well, equation C has an x and a z in it. So does this equation D that I just made. So essentially, equation C becomes my equation E, right? That's what's going to happen. So C becomes E, and I have 9x minus z equals -1. And look at that. My z's are already good to go for elimination. That gives me 3x equals a 1. Yeah. Okay. And x equals 1/3. And I did do this problem yesterday, and I did get a fraction for that. And again, I mentioned earlier that if you do get fractions for these, they should be good-looking fractions like that, not something super gross. So now I can plug the x equals 1/3 in here. That will give me y. So I have y equals -6 times 1/3 plus 6. Well, 1/3 of 6 is 2. -2 plus 6 is 4. All right, and now I know x and I know y. I need z, so I'm going to take equation B, this guy right here, y plus z equals 8. I know y is 4, so 4 plus z equals 8. I'm going to subtract off 4, and z also equals 4. And you're solved. So our ordered triple looks like x is 1/3, y is 4, z is also 4. So this required a little bit more substitution. Your brain has to kind of figure these out, and it's like a little chess game almost. You have to think a couple steps ahead, but you guys can all do it, I think. All right, so remember this was, what was this? 4.7. All right, and that might end this chapter. I don't know. I have to go and check. We'll see. All right, well, toodaloo for now.